There are many types of lighting devices in the market, but there are mainly three types of them, namely incandescent lamps, gas discharge lamps, and light-emitting diodes. In a gas discharge lamp, energy in the form of light will be released when an electron jumps from a higher energy level to a lower one. If the higher energy level has an energy E' and E for the lower one, then the energy released will be E' minus E, which is the energy of the photon. Because the energy of the photon is directly proportional to its frequency, that is, E equals to h times f, where h is Planck constant. As a result, the frequency of photon is f. There are two kinds of gas discharge lamps, which are high-intensity discharge lamps and fluorescent lamps. They have a similar mechanism for light production. In the sealed tube of the lamps, there are some gases and an electrode. The electrodes give out electrons, and those electrons will collide with the atoms. The electrons in the atoms will gain energy from the collision and excite it to a higher energy level. When those electrons return to their ground levels, energy will be released in the form of light. In gaseous state, there are fixed energy levels for the electrons, so the energy released during electronic transitions will also have some fixed values. Since the energy levels depend on the type of element used, different emission spectrums with photons of different wavelengths will be produced by different elements. Using some combinations of gases, one may obtain a desired color of light from the discharge lamps. Incandescent lamps use a hot filament to produce light. There are some inert gases and a tungsten filament in an incandescent lamp. The purpose of injecting inert gases into the bulb is to avoid chemical reactions between oxygen and the hot filament. Here is a graph showing the light emitted by ideal blackbody under different temperatures. Its peak shifts to the left, or to the direction of shorter wavelength when the temperature increases. Here is an emission spectrum of a tungsten filament, as we can see when it is at a lower temperature. Mainly red light is emitted from the filament. Atomic nucleus and electrons have random motions. Upon collision, energy will be released in the form of light. Since there are large quantities of nucleus and electrons moving in different speeds in the tungsten wire, energies of different quanta will be released. As a result, there are photons of various wavelengths, producing a continuous spectrum. Here is an incandescent lamp. The emitted light, initially reddish, will become closer to white light when the temperature of the tungsten filament increases. Typically, incandescent lamps operate at around 2,500 degrees Celsius. At this temperature, it gives out visible light mainly in the yellow and red end, and actually most of the emission lies in the infrared region, which is not the useful form of energy output. Lastly, we would have a look into light-emitting diodes. Light-emitting diode, or LED, is a semiconductor light-emitting device. It gives out light in the region where two kinds of semiconductors join. Once there is current flowing through the LED, electrons and holes will combine, giving out energy in the form of light. By using different types of semiconductors, we can alter the energy given out during the combination of electrons and holes. Photons of various wavelengths can then be produced. Therefore, we can use LED to produce light of different colors, or even in infrared or ultraviolet range.